To find the poles of a magnet, we should first understand something about Earth. I hope all of you have seen this. It is a globe replica of the Earth. It has latitudes and longitudes. Okay, and the horizontal line which is passing from the center is known as the equator. Equator has a latitude 0 degree. 0 degree latitude line is known as an equator, right? And the region of the Earth surface which is above this 0 degree line is known as northern hemisphere, and the line or a portion which is at the bottom is known as a southern hemisphere, right? Then the most farthest point at the north side is known as a north pole. Okay, so north pole is basically a point, or we can say the center of northern hemisphere, and south pole is again the two extreme points are there. On one end, opposite end is north pole, okay, and the opposite side is known as a south pole, right? Always remember, the equator has latitude equal to 0 degree, useful in geography. Sometimes it is also useful in history. Okay, so the north pole is the topmost point and south pole is the bottommost point. That means our earth basically has two poles, a north pole and a south pole. Fine. Now coming to how to find, so let's say you have a magnet. This is a bar magnet right here. You can see this bar magnet, when it is tied to a string with the help of a paper string, okay, and you leave it on the laboratory stand. So if a bar magnet is tied with the help of a string, and when it is freely suspended, that means no one is touching it, okay. When a magnet is freely suspended, then you will see that that magnet will first move to the left, then move to the right. After some time of shuffling, moving here and there, it will automatically come to a rest. So after the magnet which is tied to the string here comes to a rest, we know that the earth is having a north pole and south pole. So when a magnet comes to rest, basically one side of a magnet points to north pole, and another side it points towards the south pole. When a magnet which is tied to a string comes to a rest, it points in the north south direction. Okay, so whichever side of the magnet is pointing in the north direction, okay, is known as a north pole, and the side which is pointing towards the south pole of the earth is known as south pole of a magnet. Okay, so side which is the side which is pointing towards the north pole, we will name it as capital N, and the side which is pointing towards the south pole is known as S. We also call these north pole and south pole as north seeking pole and south seeking pole. Seeking means finding. What the magnet is trying here after being freely suspended is he is trying to find out or point towards the direction north pole of the earth, or towards the north direction of earth. So therefore we consider them as seekers. Okay, this property we use in magnetic compass that we will see in the coming classes. So the side of a magnet, bar magnet, which points towards the north pole of earth, we call it as north pole of a magnet, and the side which points towards the south pole of the earth, we call it as a south pole of a magnet. We also refer north pole as north seeking pole and south pole as south seeking pole. Seeking means it is pointing towards certain direction, okay, trying to point towards one direction. So one edge is known as north seeking pole or north pole, and the other side of a magnet is known as a south seeking pole or a south pole. I hope everyone understood. Okay, there are many ways to find north pole and south pole of a magnet. According to CBSE textbook, this is one method which is widely used. If we don't know where is the north pole and south pole of a magnet, but definitely we should know in which direction the north pole and south pole of the earth is there. Okay, otherwise you will get confused. Fine. So the point, the edge of a magnet which is pointing towards north pole is known as a north pole of a magnet, and the side which is pointing towards the south pole of the earth is known as the south pole of a magnet. Very importantly, then there comes magnetic force. We know that magnet always attracts. Okay, so what is magnetic force? The force exerted by a magnet on another magnet or another metal object is known as a magnetic force. This magnetic force can be attractive or it can be repulsive. Okay, just to understand the force of attraction and repulsion, we have to first understand two things. One, as you can see here, there is N. As you can see here, one side it is N and another side it is S. So this is one pole of one magnet and this is second pole of another magnet, and because both of them are having different name, we call them as unlike poles or different poles. So north pole N is different and alphabetically S is also different. You can consider it like this for the sake of remembering. So N and S, because they are different, we call them unlike poles, right? And whenever we have, as you can see here, we have N on one side and N on the other side also, and because both of them are alphabetically also same or symbol wise, so therefore we call it as like means same. So if two different poles of a magnet are brought together, they attract, they come close to each other, right? And when two same poles, and means like poles, same means N and N, when N and N are brought together, they do the repulsion, they push each other away. So when unlike poles N and S, not same, different poles are brought together, they come close to each other, they attract. Opposites always attract, unlike poles always attract, right? But like poles, or you can say north and north here, they always repel, they push each other. Okay, so in a magnet, unlike poles always attract and like poles always repel. Very importantly, so if you have like poles north and north, then and if we bring two magnets together, they will always push each other in opposite direction. Remember, like poles always push each other, they repel each other, right? And unlike poles or different poles, N of a magnet and another S of a magnet, they always attract each other. Very sorry, unlike poles always attract each other, as you can see here. So there is a correction needed, and you can see the magnets are also trying to come close to each other. That's all for today's class. In the next class, we will study about magnetic properties or properties of magnetic lines. Okay, and how a magnet does attraction. Very interesting. I hope you enjoyed this class. Any doubts, you can call me anytime. You can message Ashok sir, or you can put a message in the group. Thank you very much. Have a good day. Stay safe.